Guys, so in the last video we talked about the area vector and the electric flux. So today we are going to talk about the Gauss theorem, and before that we will just get to know what is Gaussian surface. So suppose a Q charge, this is a positive charge, and just draw a sphere around it with a radius r from the center, which is Q charge. Now if we draw a ds surface area on the surface of sphere, and then we draw a normal to this plane. Now this normal would be just perpendicular, or you can say normal to the surface. Let's give this the symbol of area vector. Now if we just notice that the Q is creating an electric environment, and this electric environment is represented by the electric field lines, which is also away from the plus Q charge. So these both ds and the electric field are perpendicular to the surface. This is the Gaussian surface. So this shows that this the plus Q charge is creating a Gaussian surface which is having a ds vector, and the electric fields are also perpendicular to the surface. So this sphere is a Gaussian surface. Now if we just prove that electric flux is equals to Q upon E naught charge. So to prove that, we know that the electric flux is equals to E ds. By integrating both of the sides, we get the electric flux is equals to E of ds. Now this means electric flux is equals to electric field into the surface area of the sphere, which is equals to 4 pi r square. So now we know that the electric field is equals to kq upon r square. So by putting the value of k, which is equals to 4 pi epsilon naught k into q, the Q charge upon this square of distance between the charge and the Gaussian surface into 4 pi r square. This is the radius of the electric field which is created by that Q charge. This r is the radius of the electric field, the place where we are calculating electric field, which is the Gaussian surface, and this 4 pi r square is the radius of the sphere. So by just cutting this and this, we are left with Q by epsilon naught. So we can say that electric flux is equals to E into surface area, which is equals to charge upon epsilon naught. Now the first property is to calculate the electric field due to an infinite thin wire. Suppose this is a wire which is having plus charge, and we have to calculate the electric field due to this positive thin infinite wire. So let's draw a Gaussian surface. The Gaussian surface would be in the form of cylinder because of this wire, as like this. So the electric field would be in this direction, this direction, this direction, and upward direction. And the normal to this, the surfaces would be here, here, and then to the left side. So let's suppose the three surfaces of the cylinder A, B, and C. So the total electric field created due to these surfaces would be equal to electric flux into integration of E into ds1. This is for the A surface, plus electric field B into surface area of B, plus electric field C into surface area of C. by removing the multiplication sign and integrating the surface, we will get E into ds, and E into ds cos theta. So we can write it in the form EA ds. We just integrated it, so EA into S A cos theta plus EB into SB cos theta plus EC into SC cos theta. S is the surface area and A is the electric field. So we have to just put the value of theta here. In the A surface, we can see that the electric field is in upward direction and the normal to the surface is in the right direction, so it makes a 90-degree angle. And same goes with the C surface area, but this B surface makes the angle theta 0 angle, because electric field and normal are both perpendicular to the surface and they are going in the same direction. So by putting the value of theta here, EA into SA into cos 90, we know that the cos 90 is 0. So by putting a value here, we will get just we will just get a 0 here. For the B value, we will put the cos theta as 0, cos theta 0. So EB into SB cos 0 would be equal to EB into S, because cos theta cos 0 is always 1. So EB into SB into 1 plus 0. Same goes for here. Theta is also theta is 90, so value would be 0. So now we can say here that electric flux is equals to EB into SB. Now we can here, this is the surface area of the electric. This is the surface area of the thin infinite wire, and this is the electric field which we have to calculate. So by putting the value of the electric flux here, which is equals to Q by epsilon naught, now which would be equal to EB into surface area, which is 2 pi r L for the infinite thin wire. So by just taking the values there, we will get EB equals to Q upon epsilon naught into 2 pi r L. So we can write it Q upon epsilon naught into 2 pi